Hello everyone, my name is Iris from Wu. Today we're going to talk about compensating and equivalent variations, and this is from Varian chapter 14.8. So typically when the price of something goes up and you purchase that item, then that is going to hurt your utility. But we know it is difficult to express how much you suffer using utility. So sometimes it is convenient to use the money to express how much you suffer. And this is exactly that. So here we have a story. You purchased two goods, good 1 and good 2. And now the price of good 1 has gone up from P1 star to P1 hat. So that lowers utility and you suffer from that. So how do I measure your suffering? The first way, we call that compensating variation. That's it. So I would ask you, now that the price of P1 has gone up and you're suffering, how much money do I have to give you to restore your utility level that you are as happy as before? So that's the first method. Now the second method, we call that equivalent variation, is this. We know the price of P1 has gone up, and in period 2 you are unhappy. So my question is this. Suppose let's go back to period 1 before the price of good 1 goes up. I will ask you, how much money in period 1 do I have to take away from you so that you feel as bad as in period 2? So you see, these two methods are different. Now you know the difference, we're ready to dive into our example. So in our example, both P1 and P2 were equal to 1 in period 1. Now in period 2, your P1 goes up to 2. Your budget is 100, and that is your Cobb-Douglas utility function. Notice that both your A and your 1 minus A are equal to a half. So your optimal utility bundle is equal to, we're just moving this item here, and we're going to plug in our half into the A, and also a half into 1 minus A. So after you expand that, you notice that your optimal utility is a function of your budget and the price. So we know in period 1, both P1 and P2 were equal to 1, and your budget is 100. So just plugging a number, you see that your utility level in period 1 is equal to 50. So after the price of P1 has gone up to $2, and we know the price of good 2 doesn't change, I'll ask you, how much money do I have to give you so that your utility remains at 50? So after we calculate it, we know that the money you will need in order to maintain that level of utility is $141. And I know originally you already have $100, and therefore the difference is just 41. So I need to give you $41 to restore your utility to the previous level. Now let's move on to equivalent variation. So we know that in period 1 your utility was higher, and in period 2, because the price of good 1 has gone up, you are less happy. So my question is this. If I could go back to the previous period in period 1, how much money do I have to take away from you so that you're as unhappy as in period 2? So let's calculate the utility in period 2. So we know that our utility function is m divided by 2 times the square root of P1 and P2. So I just plug in my budget 100 and the current price of good 1 and good 2, and I get the utility level 100 divided by 2 times square root 2. That gives you approximately 35.36. So I'm going to go back to period 1, and in period 1 the price of good 1 and good 2 are both $1, and I want to make sure in period 1 my utility level is as low as in period 2. So how much money would that be for me to feel as miserable as in period 2? And after I calculated, I noticed that, hey, the amount of budget is about $70.71. So I know in period 1 you had a budget of $100. That means I would have to take away $29.29 for you to feel as crappy as in period 2. So I know in Varian's book the approximate number is 30, but our calculation is basically just the same. So I hope this helps. This is compensating and equivalent variations, and I will see you next time.